Imagine you're trying to push a heavy box across the floor. You push and push, but it just won't budge. It's as if some invisible force is holding it back. This is where Sir Isaac Newton's brilliant laws of motion come in to explain the magic happening right before your eyes. Newton's laws are like a secret code that unlocks the mysteries of how objects move. They help us understand why things move the way they do, whether it's a ball flying through the air or a car speeding down the highway. These laws, discovered centuries ago, are still incredibly relevant today, shaping our understanding of the universe from the smallest atom to the largest galaxy. Newton's first law of motion, often called the law of inertia, states that an object at rest stays at rest, and an object in motion stays in motion at the same speed and in the same direction, unless acted upon by an unbalanced force. Think about it, that heavy box won't move unless a force stronger than its resistance acts upon it. This resistance to change in motion is called inertia. A great example of inertia is how seatbelts work in cars. If you slam on the brakes, your body wants to keep moving forward due to inertia. The seatbelt provides that unbalanced force to stop your motion, keeping you safe. Another fascinating example is the classic tablecloth trick. If you quickly yank a tablecloth out from under dishes, the dishes remain in place. Their inertia makes them want to stay put. Newton's second law of motion tells us how force, mass, and acceleration are all related. This law states that the acceleration of an object is directly proportional to the force applied and inversely proportional to its mass. In simpler terms, the heavier something is, the more force it takes to move it. Think about pushing a shopping cart. An empty cart is easy to push, but a full one requires much more force to achieve the same acceleration. This is because the full cart has more mass. Similarly, if you kick a soccer ball and a bowling ball with the same force, the soccer ball will accelerate much faster because it has less mass. The bowling ball, being much heavier, will accelerate much more slowly. Section 4. Action and reaction, the third law's dance of forces. Newton's third law of motion states that for every action, there is an equal and opposite reaction. This means that forces always come in pairs. When you push on an object, that object pushes back on you with the same amount of force. Imagine jumping off a small boat onto a dock. As you push off the boat, you exert a force on it. The boat, in turn, exerts an equal and opposite force on you, propelling you forward and pushing the boat slightly backward. One of the most awe-inspiring examples of the third law is a rocket launch. The rocket expels hot gas out of its engines, pushing down on the ground. The ground, in turn, pushes back on the rocket with an equal and opposite force, propelling it upward. Section 5. Newton's laws in our daily lives, from coffee cups to rockets. Newton's laws of motion are not just abstract concepts confined to textbooks, they are at play all around us every single day. These laws explain why your coffee stays in your cup until you lift it, why you don't float away into space, and how airplanes soar through the sky. Understanding these laws allows us to engineer incredible feats, from designing safer cars to building towering skyscrapers and launching rockets into space. By comprehending the fundamental principles that govern motion, we gain a deeper appreciation for the elegance and wonder of the physical world. Section 6. The enduring magic of physics. Newton's laws of motion, though simple in their formulation, have had a profound impact on our understanding of the universe. They serve as the foundation for classical mechanics, and continue to inspire awe and wonder in those who study them. As you go about your day, take a moment to appreciate the invisible forces at play, the constant dance of action and reaction, and the remarkable predictability of motion. These laws are a testament to the power of human curiosity and our ability to unlock the secrets of the cosmos. Think about the examples we've explored. Which one surprised you the most? Which one resonates with you the most? The world of physics is full of fascinating discoveries waiting to be uncovered.